measure the coastline of Australia?
From the air, wouldn't you?
How would I go about measuring the coastline of Australia? I'd probably buy a map.
I jump in a boat.
Yeah.
It's got satellite navigation. Put in my waypoints, work out my distance by the speed, and there you be.
Probably do it by boat.
Tape measure?
It's a string.
It's string.
I haven't the foggiest idea. It's a hell of a distance.
If you were going to travel around Australia and measure the coastline, how would you do it? No idea. These dogs, they don't have proper education. Yeah. Have you got a degree in mathematics by any chance? No. Did you study it?
No, I study navigation.
Navigator. How about, have you heard of fractal curves?
No. Would that be the right thing? Is that the right answer?
Well, as we can see, there are various ways of trying to measure the coastline of Australia. But the best way is using fractals. A fractal curve is a wrinkled curve, and it has a very peculiar property. It stays wrinkled no matter how many times you try to magnify it. A smooth curve has a dimension of 1, but a fractal curve, like the coastline of Australia, has a fractal dimension, a number greater than 1 that shows how wrinkled it is. The more wrinkled the curve, the higher the fractal dimension. The snowflake is a fractal curve. It's constructed by starting with an equilateral triangle, replacing the middle third of each side by the two other sides of an equilateral triangle, and repeating this process indefinitely. Inductively, we can examine the way that the process of construction produces a wrinkled curve that looks more and more like a geographical coastline. The pattern that we get from carrying out the construction seems to defy our intuition. We know that at any stage in the process, the figure consists simply of straight line segments. Yet, as the construction proceeds, it appears more and more like a coastline.
Yeah, that's all really well, but how can you prove that deductively?
Deductively, we can find the length of the curve using the following idea. Using the initial triangle, the length of each side is 1, giving us the total length of 3. The first stage of the construction involved replacing the middle third of each side by two other sides of the same length, thus increasing the length of each side of the figure from 1 to 4/3. The total length is 3 times 4/3, or 4. The next step also increases the length by a factor of 4/3. The process continues indefinitely, each time increasing the length by a factor of 4/3. The final result is a curve with infinite length, since we multiply by 4/3 an infinite number of times. We've proved deductively that the snowflake has infinite length, so the implication is that the length of the Australian coastline is also infinite. But we can't check that measurement. So our conclusion must be that the length of the Australian coastline depends on the type of measurement that we use. We can see that the snowflake curve never gets larger than the circle passing through the points of the original triangle. So we have the strange situation that a curve of infinite length surrounds a finite area. But hang on, this argument is inductive. How can we be sure that the snowflake never extends outside the circle? It's obvious by looking at the pattern, but can you find a proof that the area inside is finite?